Notes on inscribed angles from Module 10, Lesson 4. An inscribed angle is an angle that has a vertex on the circle. So this point right here where R is the vertex of QRS, this angle. And so the vertex is on the circle. That's inscribed angle. And when the vertex is on the circle, the measure of the angle is equal to half the intercepted arc. And so this arc QS is the intercepted arc. And so just quickly, if this was 60 degrees, then this would be 30 degrees. The reverse then is also true. If you know the angle and it's on the circle, the arc isn't half, the arc is the reverse of half or double, twice as big as the angle. If you are going to keep complete notes, make sure you know this is different than a central angle. If a central angle has the same measure as the arc, the angle that's vertex is on is half that measure. Right? And so it matters where the vertex is. So inscribed means inside a circle, on a circle. Inscribed, the note you need for inscribed angles, the measure of the angle is half the arc. And so this wants you to find the arc. Arc CF. So first, what are we talking about? Well, we're talking about this arc right here, which is part of this angle or connected to this angle. And so it's connected to the 40 degrees. Now the arc is twice as big as the angle. The angle is half of the arc, which means the measure of angle CF is twice as big as angle D, angle CDF. Right? So it's equal to 80 degrees. This one wants me to find angle C. Where's angle C? Angle C is right here, which means this is my angle C, which means it's connected to this arc. And the measure of the angle is half the arc. And so it is 49 degrees. So look at this picture. What is the measure of angle P? Angle P for A is half of 70. So angle P is 35. What is the measure of arc PO? Arc PO is not half because we're going in reverse. It's double the angle. The opposite of a half is to double it. So this is double the angle. Arc PO Angle A. Angle A is up here. Angle A opens up like that. And so angle A hits or intercepts that arc. Now I know it's half of whatever BC is, but I don't know what BC is. I do, however, notice that angle D also opens up to the same arc. So I don't know what angle D is, but I know it's also half of what BC is, which means angles A and D are congruent. And since they're congruent, I can say their measures are equal. I'm going to minus 3x to both sides. I'm going to add 12 to both sides. And I'm going to divide by 2 on both sides. Now, the question's asking for the measure of angle A, which is 5x minus 12. So you have to plug it back in. And you get 5 times 7 is 35, minus 12 is 23. Which also means angle D is 23, which also means arc BC is 46. So those are things you know once you have X. Inscribed polygon. Again, this word inscribed is important for us today. Inscribed means inside a circle, but also kind of on a circle. And so inscribed polygon is a shape. Polygon is a shape that's inside a circle. And so like if I have like a triangle inside a circle where the vertices are all on the circle, that's an inscribed triangle. Or if I have something with 4 sides, that's an inscribed quadrilateral, right? It's got 4 sides. Or if I have something with like 6 sides, that would be an inscribed hexagon. Right? So inscribed just means that it's inside and part of, or vertices are on, the circle. Right? And so we have 2 different rules we're going to use. One is an inscribed triangle rule. So the inscribed triangle with one side as a diameter. Is a right triangle. So because this one side is a diameter, that means down here that from F to H is 180 degrees. Well, this angle G opens up to that. So angle G is half of 180. So angle G is a right angle. So this is a right triangle. So I know angle G is 90. I also know a triangle has 180 degrees in it. So if this is 90, then this and this, F plus H, must equal 90 for the whole thing to equal 180. So all kinds of things I can know once I know it opens up to a semicircle. So if that's the diameter, then it's a right triangle. The next or last rule here is about an inscribed quadrilateral. In an inscribed quadrilateral, opposite angles are supplementary. And in case you forgot, that means that inscribed angles add up to 180. In an inscribed quadrilateral, opposite angles are supplementary. And so here angles M and K would equal or add up to 180. Angles L and N would add up to 180. If I want to try to explain this real quick, angle M opens up to this arc. That's the arc for angle M. Angle K opens up to this arc. So combined, the 2 angles open up to 180. Well, they're on the circle, so their measures are half of their arcs. So the arcs are half of 360. Combined, they total 360. So half of 360 is the 180. So opposite angles are supplementary in an inscribed quadrilateral. So when I look at the triangle one, I use that rule about triangles. KM, angle, line KM, chord KM is a diameter. So which angle is 90? Angle L is 90. And so that means angles K and M have to equal 90. Combine like terms. Oops, 90. Combine like terms. Add 14 to both sides. And then what do you get when you divide 104 by 13? You get x equals 8. Now it asks you to find k, so you plug it back in. The measure of angle k equals 5 times 8 minus 4 is 40 minus 4 is 36 degrees. Luca is creating a collection of stained glass ornaments. So this is a stained glass ornament. The ornament shown uses a quadrilateral inscribed in a circle. And I can remember my rule is opposite angles are supplementary. And so 3x minus 16 plus x minus 4 equals 180. I also have opposite angles F and D. So 5y plus 16 plus 3y plus 4 equals 180. Up top, 4x minus 20 equals 180. 4x equals 200. And so x equals 50. Down low, 8y plus 20 equals 180. I minus 20. 8y equals 160. I divide by 8. I get y equals 20. Now it's asking for the measure of angle F, which is 3y. 3 times 20 is 60. Plus 4 is 64. And the measure of angle G, which is x minus 4. 50 minus 4 is 46. So make sure you also know what the problem is asking. These are the ones we're trying in my class. I bid you adieu. Have a great day.